Here in this new lecture we are going to create an edge detector using Verilog. So to create an edge detector, here is the code of that detect the both the edges, like we have gone from either say 0 to 1 it will detect, or 1 to 0 it will also detect both the edges. Like it will detect the rising edge or the falling edge, so it will detect both the edges. So this our aim of this lecture is to create this program by ourselves. Okay, so let us firstly understand the logic, how we will create it. Let us say the initial edge was 0 and then it rise to the 1. This is our edge. So this is what? Rising edge. So how we are going to check whether this is rising edge or not? So if it is the rising edge, so we will set the positive edge as 1, else we will set the positive edge as 0. So we will do what? We will just do, we will assign positive edge as a previous. We will store this previous signal in some variable known as previous. So we will just complement this previous and we will then add this will signal, that is our current signal. So this idea will give us the concept of rising edge. Rising edge. So this will help us to detect the whether it is a rising edge or falling edge. The next one is falling edge concept. So 1 0 it is falling edge. So what we will do is we will just assign the positive edge as uh, previous, and we will do and with complement of signal. So now to detect the both the edges, what we will do, we know that if there is XOR x and y, if both of them are not equal, then output will always be 1. Okay, so if the previous and current are not same, this XOR will always show us 1. So this, using this technique we can create our edge detector. So we will create individual edge detectors. Now let's say module edge detector. So in this module we are going to have three variables, three ports. So first is input signal, the another one is input clock, and the last one is output, which is positive edge. Now let's say we are detecting whether it is positive edge or not. So we will going to use the blocking statement procedural block. Then inside the procedural block we need to assign it as a reg type, because we are assigning its value inside the procedural block, that is always at the rate positive edge of the clock. So we are desired to perform this operation synchronously, so we choose the positive edge of clock. We can use a reset also. You can just choose here the RST, and then accordingly you can use if else statement, that if reset we will assign this positive edge as 0 or whatever. So our previous one, we can declare our reg type to the previous. So this previous will store the previous value of the signal. Okay, so now we will do what? We will do begin, then positive edge using non-blocking statement assignment. We can say positive edge will be the end of previous and signal. The signal shows the current value and the previous will be having the previous value. So the here we are assigning previous as signal, that is previous. Now this let us say this time signal has a value 1 and the previous has value 0, so it will give us 1. So now it will be 1, that is old signal value will be assigned to the previous, and next time it will be 0 and this previous one will be 1. That's how it works. So we created a positive edge detector. So we just need to go to the terminal, write I verilog slash o, let's say edge detector dot vvp. uh, this is the file which we need to create to show the output in this terminal of VS Code. Okay, so it doesn't need to be of the name of the file that you choose, so it can be any name. I just gave it for the simplicity and the comprehensiveness. So now this time you need to assign the original name, that is edge.v. So we will give the value of the test bench here. Module definition: edge cannot rest inside the module edge detector. Okay, one second. We created a test bench here. Signal clock and wire. Signal clock output reg p. Any problem? Oh, okay. We didn't do the end module. End module. Okay. Let me clear the test. And here we are. Now at last, to see the output, we will do what? VVP edge dot edge detector dot VVP. Before, so it, when signal goes from 1 to 0 to 1, it will show 1, and the next time it will go from 0 to 1, it shows that yeah, it is positive edge. Let us look over test bench also, then we will see what happening here. So in the test bench I have included this edge detector file. We declared our test bench variables, reg type as signal and clock. Then we instantiate our module. Then we set the clock here with the frequency of 10. Then here we have a signal, initial block. Inside this initial block, let's say I have set the signal initially at 0 for the simplicity. Then there is, in this kind of problem, there occurs a edge race around condition. So let's say we provide a little bit delay to get a good output. So we are assigning the value of signal here. We are then at the positive edge of the clock, just before the positive edge of the clock. This statement means we are doing this around the positive edge of the clock. But why I am doing it before the positive edge of the clock? Because if I will do it around the positive edge of clock, it will give me the race around condition and sometimes give me problem. Okay, so that is why we are assigning it before the positive edge of the clock. Then just 1 second delay, we are displaying our values here. Then the same thing here, we are just copying and pasting this all. So we created our test original file here. Let us go again, see the, so at 0 1 we have got 1, again at 0 1 we got 1. Let us once again create this file for negative edge detector. So positive edge, we will assign the variable same as PE. Now this time we only need to change is, we will just complement this signal. Now let's go ahead. So this time when signal goes from 1 to 0, it shows here negative edge. It goes from 1 to 0, yeah, it is again negative edge. That's it. Now in order to check whether either is it a fall or a rise, you can check both of them by using an XOR. So yeah, you can see the signal rise from 0 to 1, yeah, it is rising edge. 1 to 0, yeah, it is falling edge. Yeah, here it is a rising edge. Yeah, 1 to 0, yeah, here it is a falling edge. So through this way you can create an edge detector. I have uploaded it in my GitHub repository. You can access my GitHub repository. If you want, I will provide it in the description also here. So today we discuss how to create a positive edge detector, negative edge detector, and both the edge detector. Here is a test bench which we created. I already created it, so because test bench is not a big deal, only the creation of logic here, that is a main thing for us. Okay, so that's it for the lecture. Thank you.